Okay, today I'm gonna go over classwork 23, which is over chapter 7. In chapter 7, we're gonna cover sets, basic counting principles, permutation and combination. So these are the sections from chapter 7. And I'm gonna go to the actual assignment. And we're gonna go over homework 23, chapter 7. So here we go. I'm gonna start with number 1. And you're going to go one by one, and I can explain it's about sets. So first we're talking about sets. So set is a list number with not repeating number. So here we have set, the first one is 3 and 5, and the second one is 1, 2, and 5. And the question is, what is the interception? So the interception is this symbol, which means what they have in common. In set 1 and in set 2, what is the number they have in common? Obviously, that's the number 5, because the first one have 5 and the second one have 5. So that's what I'm going to put in the answer box here is 5. So if they have more than one number in common, you're going to put comma and so on. Now, if they don't have nothing in common, then it's going to be empty set. Okay, so that's how you do this, and you're going to check the answer, and that's fantastic. Okay. Going to the next one. Here we have the union symbol. So the union this is the symbol for union. And union means you include all the elements from the first set, also all the elements in the second set, but you're not repeating them. So it's going to be this one plus 5. Now 6 is repeating, so I'm not gonna write that again, and 9 is repeating, I'm not gonna write that again. So my set of the union of those two sets is gonna be, the order doesn't matter, just make sure you have all the numbers, 6, 8, 9, and 5. We're not including 6 because 6 is already included in the first set, and we're not including 9 because it's repeating. And we're gonna check that, it's also correct answer. Then we're going to go to the next one where we have to find the union again. And we have to choose the correct answer here. So it's a multiple choice. So when you find the union means you're going to include the first two numbers, 2, 4, and then the numbers from the second one, which are not repeating. So I have 1, 3, and 5. So this is going to be the set of the union because we don't have this repeating numbers in both sets, and the union is going to include all of those numbers. So I have 1, 2, 3, 4, and 5. So obviously this is my right answer, B. Okay? Because the order doesn't matter, so you can put it in this order or in that order, doesn't matter. Okay, then going to the next one. What it says. Okay, we got that. We're going to the next one. Number 4. So here we have the interception again. So we have 1, 4, and 7, 2, and 6. So looking at those 1, 2, 4, 6, 7, it's empty. There's nothing in common, right? So that's what I'm gonna pick for the union. I'm sorry, the interception. They don't have anything in common. So it's an empty set. And we're checking that's correct. Going to number 5. Okay, so here we have U, it's universal set. And you have also the set A. And let me explain what that means. So you have usually in the Venn diagrams, you're representing the universal set, like rectangular box. So this is the universal, which includes everything. And then the set A is somewhere, okay? And the numbers in the set A are 20. I'm going to put them inside, 22, 25, and 26. So these are the numbers in the set A, and the union set include those numbers plus something else. And the numbers which are not in A are called A prime, which is called complementary. So this symbol here means complementary of A, which means everything outside. So looking at the set A and the numbers which are not in A are going to be in the, so this here area outside in this Venn diagram is called A prime, complementary. So the complementary is going to be 20, 21. So it's going to be 21 because 20 is in A, 21 is out, 22 is inside, 23 is also outside, 24 is also outside, 25 and 26 are inside A. So those three numbers are the complementary, which are outside of A. Okay? And that's what you're going to put here. So the outside are the numbers which are not included in A, which are 21, comma, 23, 24. Okay? So that's well done. So that's how you do those. And then you go into the next question. Now here we have the Venn diagram. I show you a little bit. Looking at this Venn diagram, find the indicated number of elements. So NA means how many elements or what is the number in the A. So this is A. So this is A. So when I add 29 plus 40, that's going to give me my answer, N of A. So it's going to be 69. So we're just adding the numbers in the area of A, whatever their numbers given. Okay, that's good, excellent. And then we're going to the next one. Next one, we have another Venn diagram and you have to find the union between A and B. So union means what is in A, what is in B. So that means I'm going to add all these three numbers. So I'm going to add 21 plus 5 plus 38. 64 is my answer. Okay, so that's what I'm going to put here, 64. And when you check it, it says fantastic. Okay, going to the next one. The next one is another one. So we have this Venn diagram and we have shown that the set, we need to find how many elements in set A prime. A prime means everything outside of A. So what are the numbers outside of A? 24 and 40, right? So we're going to add 24 and 40. Because these 40 here represent the numbers outside of the union of A and B. So when I add this, I'm going to get 64 also. And let's see, that's good. The next question is about, we have indicated number of elements by referring to the table of enrollment in a finite math class. Let the universal set is the set of 190 students in class. So this is what you have. The universal set is 190. A is the set of students from college A, a College of Art and Science. So this here is A, set A, Art and Sciences. And B is the students from College of Business. So this is B. The second row is B. So this is A, this is B. Okay. F is the set of freshmen. So this is F. And S are the sophomores. Find the number of students in S. So what is the student in S? That means how many sophomores? It's going to be 8 plus 28. So I don't need to draw this. So 8 plus 28 is 36. And that's right, okay? Let me clear that. And then you go into the next one, next question, number 10. So here we have something similar again, but they're asking a different question. So here we have find indicated element. So here you have 115 students is the total number. A is the set of college of art and science. So this is A. This is B of business. We have freshman and sophomore again, right? S is the set of sophomore. Okay, find the number of students A intercept of with S. So that means they're asking how many freshmen are, no, I'm sorry, how many sophomores are in college A. So this is the interception between A and S. Okay, so it's gonna be, the number is gonna be 9. And that was right. The next question, we have another one, something like that, but here we have 128 students given, and they want us to, again, the same idea, but the numbers are changed, different numbers, and they're asking A union of B. So A union of B is gonna be just adding all these numbers. So when I add 17 plus 70, and also 12 and 29 is gonna be 8 and 1, 2, 3, 10, 128, which is the total number, right? So it's gonna be 128. And that's right, okay? So they're asking A union and B because they don't have another college. If they have another college, probably it's not gonna be that many, but this is how it is in this one. Okay, so here we have something else. What do we have? A college offered 3 introductory courses in history, 1 in science, 2 in mathematics, 4 in psychology, philosophy, and 2 in English. If a freshman take 1 course in each area during her first semester, how many courses selections are possible? Okay, so here we're gonna do something. So we have 2 courses on history. I have 2 history, 2 science, 2 math, and 3 psychology, and 4 in English, right? So what you need to do is, the question is, if the freshman take 1 course in each area during her first semester, how many course selection are possible? So I'm gonna multiply. How many in history? 2. Multiply by how many in science? 2. How many in math? 2. Times how many in philosophy? 3. Times how many in English? 4. So when I multiply these numbers, I'm gonna get how many courses selections are possible. So multiplying 8 times 12 is 96. So when you multiply 96, when you multiply those numbers, you're gonna see the selections, the possible selections. 96, let's check that. Okay, that's good. What else they're asking? If a part-time student can afford to take only 1 introductory course, how many selections are possible? So here we're just gonna add all the possibilities. So 2 plus 2 plus 2 plus 3 plus 4. So we're adding the numbers. We're adding 2 plus 2 is 4, plus 2 is 6, 9, and 4, 13, right? Did I add it correctly? Let's add it backwards. 4 plus 3 is 7, 9, and 4, 13, yes. Let's see. Okay, that's right. And is that the next question? Yeah. So small combination lock on a suitcase has 3 wheels, each labeled with the 10 digits 0 to 9. How many 3-digit combinations are possible if no digit is repeated? If digits can be repeated. A successive digit must be different. So here we have the number of different 3 combination possible is related is how many. So you have to find that. So this is how you find it. So here we're gonna find the combinations. So they're in between 10 different digits from 0 to 9. We're going to pick 3. So this is how you write it, 10 out of 3. You're going to pick 3 out of 10. And that is starting with 10. And you go 9, like permutation, but you're going to continue as 3. You do 3 digits, 3 consecutive digits you're going to multiply. And then when you multiply those 3 numbers, you're going to get all the possible combinations with no repeating digits. And so I'm multiplying 720. I think that's what you get, 720. And let's see. Okay, that's right. The next one is the number of different 3 digits combination possible if the digits can be repeated. So here, if the digits can be repeated, then you're going to start with all the possible the possible digits you're going to pick from 10 with exponent how many you're going to pick. 10 cubed is going to be 1000, right? So that's what you're going to get here, 1, 2, 3 zeros, right? Okay, that's good. And then we have number 3 digits combination possible if consecutive digits different is. So here, let's see what you're going to do. So here we have, we're going to start with the 10 possible digits. And then the number of different 3 digits combinations. So the first digit you're going to pick is from 10 possible. This is the 10 possible digits. And then the next one, because we have, must be different. So they're going to be 9 different combinations. And then you're going to pick one more with 9. So when I multiply this, I'm going to have 9 times 9 is 81. A 1 with 0. Oops. Okay. And that's right. Okay. So that's how you do that, because there are 3 digits. Now, if there are 4, it's going to be 10 times 9 times 9, 4 of those. Okay, depends. So this number here, there should be 3 multiples. Okay, so that's how you do this one. And going to number 14. Number 14, you have how many different license plates are possible if each contains 2 letters followed by 4 digits. How many contain no repeated letters? So so here we have, so they're going to be so we're doing combination. And we have, so 2 letters. So there, how many letters here? 26. And then you have 4 digits. So you have also combination of the 4 digits, and you're picking out of 10 because there are 10 possible the digits from 0 to 9. That. So first you're gonna start with the letters. So 2 letters picking out of 26. So it's gonna be 26 times 25, and that's gonna give me whatever number we get. And then for the second one, because we can repeat those 4 digits, so technically I'm multiplying by 10 4 times, because you're picking 4 out of 10. And when I multiply this number, I'm gonna multiply those numbers, and that should be my answer. So 26 times 25 is 650. And then I put 1, 2, 3, 4 zeros. And I'm gonna put it here. So 26. I'm sorry, 65. The final answer. 65 with 1, 2, 3, 4, 5 zeros. Okay, let me see. I put it, I did something wrong. Just a second. Okay, sorry, here I make mistake. This is 26 times 26. Yeah. And it's gonna be, when I multiply that, it's gonna be 676. 676. And that's gonna change here. And then I have 2, 3, 4. Okay, and that's right. Okay, so here we multiply 26 times 26 because we can you have combinations where you can repeat those, and then we have to find how many the different possible license plate if no letters or numbers are repeated. So what you're doing here, we're gonna we have no repetition, so the letters are not repeated. So what you're doing here, we're gonna multiply. So this is where you multiply 26 times 25. That's gonna give me the letters. And then you start with 4 digits. So you start multiplying by 10, 4 of those, 10, 9, 8, and 7. So these are the letters, and then the second part is the digits. So when I multiply those numbers, I should get my answer. So I have 26 times 25, 650. And that I multiply by 90 times 72 is, I get, when I multiply all those numbers, 6,480. Let's see, 6,480. What I did wrong, let's see again. Okay, so here I'm doing the math. I think I make mistake in the calculations. So when I multiply, I'm using my calculator and I don't know what I press, but when I multiply 26 times 25, I get 650. And then I multiply 10 times 9 is 90. Multiply by 72, that's 6, hold on. So multiplying 10 times 9 is 90. Multiply by 8 is 720. Multiply by 7 is 5,040. And when I multiply 5,040 times 650, I get 3,276. Okay, that's more like it. Let me do it one more time. 650 times 5040 is 3. Okay, that's right. So that's gonna be, I mean, it should be a big number like that. So I always use calculator and double check your word, because sometimes if you press something different, it's gonna give you a wrong number. So 3,276,000. 1, 2, 3. Okay, let's see it again. Okay, so that was good. Then you're going to the next question. So here we have a class of 30 classic music students, includes 10 who play the piano, 70 who play the guitar, and 5 who play both the piano and the guitar. How many students in the class play neither instrument? Okay, so let's solve that. So here we can do Venn diagram to solve it. Okay, so we have there are 30 students. So if you use the Venn diagram, the total number is 30 students. That's the universal set. 10 who play piano. So the piano are 10, and 70 who play guitar, piano and guitar, and 5 who play both the piano. So 5 is the number inside here, 5. Now, because the piano are 10, so if this is 5, this is also 5, because 5 plus 5 is 10. because if you look at the set of the number of the people who play piano are gonna be 10, but 5 of them play also guitar. So that's why in the common area here. And also the guitar, the students who play guitar are 17. So 17 minus 5 is gonna be 12 is the number here. And they're asking how many students don't play anything. So they're asking what is the number outside of all of those who are playing instruments. So what you're doing, you're gonna add 5 plus 5 plus 12. So that's 22. And you're gonna subtract from 30 because 30 is the total number. And that gives me 8, right? Because 8 plus 22 is 30. So the students who don't play anything are 8. And using Venn diagram, it's a really easy way to do that. Okay, going to the next. So here we have the same similar example. We're going to use the Venn diagram also. We have 100 people. So the total number, the universal set is 100. Include 37 people who speak Italian. So these are the people who speak Italian. 66 speak Portuguese. So this is Portuguese. And 16 who speak neither language. So neither is going to be outside. How many people in the group speak both Italian and Portuguese? So that's what they're asking me here. What is X? Okay. And I know that if the people who speak Italian is 37, so this area here is going to be 37 minus X. This area here is going to be for Portuguese is going to be 66 minus X. So when I add all these areas, I'm going to get 100. So that's going to be my equation to solve. So I'm adding this area plus this area plus this area plus this area. The total is 100. And that's the equation. And that's going to give me X, the people who speak both Italian and Portuguese. So I'm adding 37 minus, oh, it's not 37. Sorry, let me clear 37 minus X plus X plus 66 minus X plus 16 equals 100. So obviously X and X cancel. I can add X, move the X over, and I can subtract 100 also. So let's see what we have. We're adding 66 plus 37 plus 16. That's 119. When I subtract 100, it's going to be 19 equals X. So that's my X. So the people who speak both language are going to be 19. Okay, so that's how you do that. Use the Venn diagram. Okay, then we have another one where you have a survey of 1,200 people in the certain city indicates that 870 own microwave oven, 75 on DVD player, and 590 on microwave oven and DVD player. And they have a few questions here to answer. So let's draw a Venn diagram again. So we have the total number of people in that people surveyed, 1,200. Some of them have microwave. So this is the set of people who own microwave, and these are the people who own DVD player. And 590 own both. So this is 590. So the number of people who own only microwave is going to be, so the number here is going to be, we're going to subtract 870 minus 590. So it's going to be 280. So this is 280. And then the number of people who own only DVD player is going to be 750 minus 590. It's gonna be 160. And the question is, how many people in the survey own either a microphone, a microwave, or a DVD player? Or means finding the union between, so you're adding this, the union between both sets. So the first question you're gonna answer, you're gonna add 280 plus 590 plus 160. So this is when they own microwave or DVD. So we add in 1723, 130. So that's what I get for the first answer. 130. Okay, and then the next one is how many owned neither. So how many own nothing? So it's going to be the answer here. Here. So in that case, you're gonna subtract from 1200. You're gonna subtract 130, right? And that's gonna give me 170. So 170 on none of those. Okay, and then the next one on a microwave and do not own the DVD. So the area where they own microwave, but not, so there's going to be only this, only this area, because it's a 280 on only microwave, but not DVD. There's going to be 280. And let's check that. Okay, that's good. And that was actually the whole question. And then going to the next question. Next question is about set A and B again. And pretty much doing the same. Cable TV has 8,000 subscribers in a suburban community. The company offers premium channels A and B. If 2,500 subscribers receive channel A, 198 receive channel B, and 5,020 do not receive any premium channel. How many subscribers receive both? Okay, so here we're doing the same we just did, right? So we have the total number, it's 8,000. We have company A, company B. We have, this is the X bot. So A is gonna be 2,500 minus X. So this here is gonna be 190.80 minus X. And 5 to 20 don't receive any channels. How many receive both means interception between the two sets. So you're going to set up equation. Again, you're going to add everything inside the box is going to be equal to 8,000. So you're going to solve so 2,500 minus X plus 1980 minus X plus 5220 equals 8,000. And then you're going to cancel those two. You're going to add X to move it over. And you also subtract 8,000. And then when you add the numbers, you're going to get X equals, so you have 2,500 minus 8,000 plus 1980 plus 5220 equals 1,700. That's what I get. Let's see if I press the calculator correct. 1700. And that's right. Okay, next question. Okay, so here we have this one. Let's see. So let's see, we have the table at the right, give the number of male and female workers earning at or below the minimum wage for several age categories. So we have to complete A to D. So first one, they're asking how many males are of age 20 to 24 and are below the minimum wage. So we have, so the category 2024 is here, and below minimum age, at minimum below, it's how many male? So what is that? 121, right? Let's see. It should be 120, 121. That's what it says. Oh, okay, let's check it again. Okay, so here actually what you have is the workers are given in thousands. So that's what you need to be careful here. So 1,000 means you're going to put 121,000, three zeros. There you go. That's what you're missing. So be careful. All these digits, all these numbers here, it's in thousands. Okay, so you have to be careful about that. So the next one is how many females of age 20 or older. So it's going to be 20 or older minimum wage, and females. So females, so it's going to be this one plus this one, right? So we add in, what you adding? What is the number here? Hold on. I'm going to delete this so I can see better. So we add in 171 and 600. So that's 171, 600. It's 771, and you have to put the thousands after that. 771,000. Okay, that's good. And then the next one is asking about, let me clear all that. How many workers of age 16 to 19 or males earning minimum wage? So here we have to find how many workers 16 to 19. 16 to 19, this is the total of workers, right? Or male earning minimum wage. So male at minimum wage is this one. So you're adding those two and you're subtracting this number because this is repeating, because you're adding this to both of those totals. So you're gonna have 813 plus 1,143. That's 6,591, and you're subtracting 351 because you're adding this number two times, one to the males at minimum wage, one to the age 16 to 19. So when I subtract, I'm gonna get 5,061, and don't forget the 3 zeros after that, because everything is in thousands. So let's check that. So that's how you do OR 1605,123. Okay, so that was right. And then I have another one. Let me clear all that. We have how many workers earn below minimum age? Below minimum wage. So let's see how many are below. Below minimum wage is this one, and below minimum wage is this one, right? We're adding the totals, male and female. So we're gonna add 356 and 1,165. It's gonna be 1, 2, 5, 1, and don't forget the thousands. So it's 1,000,000 and 521 with 3 zeros. Okay, that was right. And then you're going to the next one. Here we have 13,588 people voted for politician in his first election, 12,000 voted for him in his second election, and 7,000 voted for him on the first and second election. How many people voted for this politician in the first or second election? So we're going to draw a picture again, Venn diagram. That's what is called Venn diagram. So you have people who voted for the politician the first election and people who voted for the second election, right? And the total number, the people who voted in the first and second is the middle part here. So this number here in the middle, the common area, is going to be 7,905. Then if I want to find the numbers for the first election, so it's going to be 13,588 minus 7,905. It's going to be 15, 6, 12, 5. So the number here is going to be 5683. And then the number here for the people who voted only in the second election is going to be 12,723. You subtract the common area, which is 7,905. And that's going to be 13, 8, 7, 8, 11, 4. 818. So that's the number. And the question is, how many people voted for this politician in the first or second election? So you're going to add here this number plus this number plus this number, because this is the area where you have or. So when I add, I'm going to add it here, 7,000 this, then 5,000. Let's do this. Let's delete this. So we're gonna add 5683 and also 4818. So it's gonna be 6 and 1, 0 and 1, then 24, 9 and 9, 18. So that's what I got. Let's check it. 18, 406. Okay, that was right. And we're going to the next one. So what is 3 factorial? 3 factorial is 3 times 2 times 1, which is 6. And if I have in general n factorial, that's n times n minus 1 times n minus 2 times all the way to 1. That's the definition. So the answer here should be 6. Okay. Oh. Oh, I'm sorry. You need to click here. The value is an integer. Okay. I mean, it's one. I just didn't look at the right one. Yeah. So it's an integer. Of course, 6 is integer number. I didn't read what it says there. Okay. So that was right. And here you're just using the formula for combination, and we just did that, right? Let me clear that and let's do that. So here we need to find a combination, and this is the formula you're going to use. So using the formula here, which is C, and so when you pick R out of N, depends what are the numbers here, doesn't matter. It's going to be always N factorial over R factorial and then N minus R factorial. So here we just replacing the numbers we have given. So we have 9 and 2. So combination 9 and 2 is going to be 9 factorial over 2 factorial, and then 9 minus 2 factorial. And you can just plug it like that in the calculator. So here we can use symbol up calculator, which I'm going to show you how it is, how it works. So these are the questions I have so far. So if you go to symbol up, you can use that calculator and plug it in. So I'm going to enter here a fraction, and you do 9, and then you just put shift 1, give me the factorial, over, now in the denominator, you have to enter 2 factorial parentheses, 9 minus 2 factorial. Just put it like that. And the answer is 36. So that's what we have here. So the answer is 36. Here again, read it, it's integer. The value is integer, obviously. Integer, not integer. Of course, it's going to be integer all the time. What I got, 36, I think. Let me double check. Yes, I got 36, yes. Okay, and let's check it. That's right. Next one is permutation. So here we have a formula again. So here's the formula. I'm going to write the formula here for you. We have the permutation. So if it says P, you're going to use this formula. N and R is going to be N factorial over N minus R factorial. So that's the difference with this little R factorial in the bottom. So permutation is this formula. So just going to plug the numbers. You have permutation 7 and 2. So it's going to be 7 factorial over 7 minus 2 in parentheses factorial. So that's what I need to put in my calculator. And of course, here I'm going to pick its integer because you're always going to get integer number. Okay, it's not fraction, it's not decimal, always going to be integer. So let's put it in. So I have 7 factorial. So I'm just changing the numbers. I don't have this in the bottom, and I have 7 minus 2. So when it's permutation, you don't have that in the bottom, and that's what you get. And the answer is 42. So we get 42 here. Okay, and that's correct answer. Okay, the next one is a horse race. In a horse race, how many different finishes among the first 3 places are possible if 20 horses are running? Okay. Exclude ties. So here we're going to use, it says exclude ties. That means we don't have repetition. So when you have no repetition, we're doing permutations. So permutation is the formula you're going to use. So this is no repeating. And we're going to use the formula for permutation. So here we need to find the permutation, the first 3 places, and the 20 is the all possible things you can pick from. So it's going to be 20 factorial over 20 minus 3 factorial. And then the calculator is going to give us the answer. So we have 20. And then here we have 20 minus 3. Like that, okay? And we get, it would be quite 6,840. 6,840. Okay, that was good. So next one we have what you have here. How many ways can a 4-person subcommittee be selected from a committee of 8 people? And how many ways can a president, vice president, secretary, and treasurers be chosen from a committee of 8 people? So here we're going to use one of those formulas again. So here for this one, we're going to use permutation combination. So we have the number of ways to select 4-person subcommittee is So if you have combination is when the order is irrelevant, the order doesn't matter. And you use in permutation if the order is important. So when you pick, in how many ways can a 4-person subcommittee be selected? So is the order important? In this case, no. It's not important, the order in that committee, right? Okay, so here we're going to use combination. So we have to find combination. We're going to pick 4 out of 8. And that's what you're going to plug it in. So we're going to have using the formula for combination. So it's going to be 8 factorial over 4 factorial times 8 minus 4 factorial, which is exactly 4 factorial. And we're going to get that from the calculator. We're going to get the answer. So we have 8 factorial over 8 minus 4. And I have to put 4 factorial in front because it's a combination. And we got 70. So the answer is 70. And we're checking that. Okay, that's good. And then the next one is to choose the president, vice president, secretary, and treasurer. So here it's also 4 out of 8, but here it's important the order. So in that case, you're going to use permutation. So you're using the other formula where you're doing the permutation formula. And you're going to have 8 factorial over 8 minus 4 is 4 factorial. Or you can just write it 8 minus 4 like this. And then calculator is going to give us the answer. So I'm just going to delete that 4 factorial in front. And we got 1,680. Okay, and that was right. Okay.